So given that picture that was given to us, the question, let's say x approaches c. Use the graph, okay. Unless I'm blind, I see c here, not a 1. Let me just make it bigger. This is the limit. Where's c? Oh, c equals -1. It's written up there on the top. I'm just blind. It says c equals, in big writing, -1. I'm looking for it, going, what is c? It says find the limit of f of x as x approaches c from the right side, which means find the limit of f of x as x approaches, we said c is what? -1 from the right side. What is the value as c approaches -1 from the right side? This is the -1 from the right side. The right side is right here. What is that y value equal to? What's that number equal to?
-3.
Yep, -3. What's the limit, the second part, of f of x as x approaches c from the left side? Again, we're talking about -1 here. From the left side, that's before you get to -1, right here. What's the y value there? Doesn't that look like -3? The left matches the right. So the next question is, what's the limit of f of x as x approaches c? It doesn't say which side. Since the values are matching, the result is what? -3. It says, is this function continuous at x equals -1? Well, let's look at it. Do you have a limit at -1? Yes. What are the three conditions to be continuous? You must have a limit. We have one. The function must be defined at -1. What is the value of x? The value of y when x is -1? -3. Condition number 2 is satisfied. And what's condition number 3? The two answers to be continuous must be what? Equal to each other. So is the limit of f of x as x approaches the -1, does that equal to f of -1? Yes. Is the function continuous? Yes. If you look at the picture, you can see there's no hole in it at x equals -1. So you know from the picture the answer is yes, it is continuous. But if you want to see the math behind it, rule 1, 2, 3. 3 conditions have to be yes, yes, and yes to be continuous. Number 2. Make sure you have a large piece of paper here for number 2. Find the limit of delta x, as delta x approaches 0. They're actually saying 0 plus. Okay, from the right side, of 2 over x plus delta x minus 2 over x over delta x. If it exists. If it doesn't, write DNE. Well, they don't tell us what x is. This is number 4. My mistake, I wrote 2, 4. I'm out today, I don't know. Well, direct substitution. I get 0 on the bottom. I can tell you that quickly. I got to figure that out. Well, let's look at that problem first. Maybe I can simplify it. If you look at the top, you're adding fractions, right? Or subtracting fractions. Well, anytime you add or subtract fractions, what do you need? Don't you need the LCD? And what's the LCD? X times x plus delta x. It's the multiplication of these two. You have two different factors. So you need to multiply the top here by what to make it look like this? Or the bottom here. What do you have to multiply this by, looking at this? What do you have to multiply this by to make it look like this? Isn't it missing an x? And if you multiply the bottom by x, you're going to multiply the top by x. What's 2 times x? 2x, bless you. To make this one look like this, it's missing what? X plus delta x. So let's multiply the top and the bottom by x plus delta x. So now we'll make it one fraction. X times x plus delta x. And what are you going to have on the top? Here's the 2x. This will be minus what? 2x minus 2 delta x. It's minus, not a plus, because there's a minus here. That's minus the whole thing. Everyone see why that sign's a minus 2? Because this minus here, it's minus 2 times that and minus 2 times that. And notice these will cancel each other out. So you end up with, it doesn't really matter if it's plus or not a plus here. It's going to disappear in a minute. You'll see that. When you look at that, that looks like negative 2 delta x divided by x times x plus delta x. But the whole thing divided by delta x, right? This fraction divided by delta x. Well, when you divide by delta x, that's the same as multiplying by what? 1 over delta x. Very good, Jay. What's nice about this now, this delta x will cancel that delta x. Top and bottom. So what's left there? The limit as delta x approaches 0, negative 2 over x times x plus delta x. Now let delta x be 0 or 0 plus. Who cares? Delta x is 0. What do you have? Isn't that negative 2 over x squared? Because we didn't tell you what x is, so it's not going to be a number. It's going to be a function of x. Yeah. Negative 2 over x squared. So I just played with the algebra. That's all I did here.
So to get rid of the delta x, you substituted it after you simplified.
Correct. After I get to this point, I replace delta x with 0. It says 0 plus, Jay, which means 0.00000001. So you can just drop it.
What's that on the bottom, on the last term in the middle? Is that a 0?
Here?
In the middle?
Here?
Yeah.
That's, yeah, so replace delta x with 0.
Oh, Oh,
So I'm taking the delta x, putting 0 plus. So I put 0, 0 plus, really doesn't matter. Any question on this? Was that you, Adam, asked the question? Anything? Any more on this one? No? Okay.
how far, can you number 5?
5? Okay. I have more questions, but I'll do 5.
Yeah, never mind.
No, it's all right. 5 actually is the next one. I got a few more still left here, but 5 is the next one on the list there. I told you I'm a little OCD in me. I like them in order there. You know? Number 5, find the limit as x approaches pi of 8 cotangent x. And again, a lot of us not familiar with the cotangent and secant, cosecant, so we'll change that to sine, cosine. Cotangent's cosine of x over sine of x. And if you try direct substitution, 8 cosine of pi over sine of pi. I have a problem. I know sine of pi is 0. Cosine of pi is negative 1. That's negative 8 over 0, which is a problem. And at this point, I really don't have any other way to simplify this. I can't think of anything. You know, either my brain is shot or I can't think of any way to simplify that. So when everything fails and I don't want to kill myself, what's my last resort? The table. We'll make values for we'll look at from the left side and the right side. I don't know why I made connected here. So let's look at from the left side and the right side. Let's take values for x. And let's go to the calculator and find 8. Because I don't have a cotangent on mine. It's 1 over tangent. I can do that. Or cosine of x over sine of x. Now, what is pi equal to? On your calculator, what's pi equal to? Isn't that 3 point? Here's what pi equals to. 3.141592654, right? So let's look at it from the left side. Values before I get to that, from the left side. How about 3.1? How about 3.14? How about 3.141 or 2? How about 3.1416? Notice I'm getting closer and closer. And see what the answer to that is going to be. And from the right side, it's going to be bigger than this. Maybe I'll try the 3.2. 3.16 is bigger than 1.4. 3.15. 3.142. Notice I'm bigger than 3.141. 3.1416. I'm trying to stay just a hair bigger than each digit there. That's you approaching from the right side. So I get the left side and the right side, and I'll try to see what the y value for each one to see if I can see the result. So that's 8. Let me just clear that. Y equals 8 times cosine x divided by sine of x. Okay. Let's try 3.1. Make sure degree in radian mode. I got negative 192.2. 3.14. Negative 5023. You can see where we're hitting. 3.142. Negative 80,000. Do I have to hit the next one? 3.1416. The calculator says, where is it? Negative 1.09 times 10 to the 6. So you can see that number is going toward what? Negative infinity, right? Let's look at it from the right side. .2. 3.2 gave me 136.81. 3.16. 434.56. 3.15. 951.53. 3.142. 19639. Do I have to continue? 3.1416. 1.09 times 10 to the 6. So where's that number going toward? Plus infinity. So what is the limit of 8 cotangent x as x approaches pi? What's the answer to that? DNE does not exist. Notice mathematically I couldn't simplify this. Not much I could have done to simplify it. I don't know of a trick off the top of my head where I can play with the trig and the algebra and all that stuff. Nothing came to my mind. So the last resort is my table. Number 9, f of x equals 3 over x. And the question is, find the value of x at which f is not continuous. F of x is not continuous. What do you think? Let me ask you one quick question. What's f of 0? Undefined. Function is not defined as 0. What does that mean? Has to be defined at that point to be continuous. Right there, on the spot. I know it's not continuous there. Undefined. So I know f of x is not continuous at 0. Not continuous at 0. If I graph that, this is what my graph will look like. What do you notice at 0? You got a hole in it. It's continuous anywhere before that, anywhere after that. But not as 0 because the function is not defined as 0. Any other value, the function is defined. And it has a limit. So that's the only spot the function is not continuous. The question, can you remove this discontinuity? What does that mean, can you remove it? Is there a way you can simplify? If you simplify that, I'll show you what removable discontinuity is. I'll make one my own. Let's say I gave you this. What's the value of this function when x is 0? What's f of 0? Undefined. But can you remove that discontinuity? Is that removable? Can I simplify this function where if I plug in 0 later, when I simplify I have an answer? Well, let's see. Can I factor anything out of the bottom? You can take an x out. What's left? And what happens to the x's now? So f of x, when you simplify it now, is what? 1 over x squared plus 4. Now what is f of 0? 1 over 4. That's a removable discontinuity. The function was undefined, has no value, but when you simplify that, that's no longer an issue. That's called removable discontinuity. So in that question, when they said, is this discontinuity removable? The answer is no in the previous one. In this one, yes it is. But in the previous one, you can't remove it. There's not much I can do to get rid of that 0 on the bottom. Here, yes, I can remove it. So that's not a homework problem, that's something I made up. So that's why there's no number on it. So the topic of this, removable discontinuity. That's what we call this, removable discontinuity. Let's continue with the problems. The next one was number 15. G sub x equals piecewise function here. It looks like this. 9 sine of x over x if x is less than 0. A minus 7x if x is greater than or equal to 0. The question, find the value for a that will make G sub x continuous. There's one number we can replace a by that will make this function continuous. So what is that value? Well, remember, to be continuous, there's 3 conditions. What's the first one? F of x must be defined. So f to be continuous at, I should be specific, x equals to 0, because that's where the break is. Remember, this is a sine function. A sine function is always continuous. This is straight line. That's always continuous. So the question, are these 2 pieces going to meet each other or not? Because the sine function looks like this. So it's only good for x less than 0, right? So that means to the right of 0 is missing all of this. The other function is going to be a straight line. So it depends on a. If it looks something like this, is that continuous? No. But if I pick the right value for a and plug it in, it might come right there, and it goes like this. If I can do that, that makes that function continuous. So what is f of 0? What is the value of the function when x equals to 0? Because to be continuous, the function must be defined at that value, at 0. We know each piece by itself is continuous. The only question is, are these 2 pieces going to be touching each other such that there is no hole in them? So if there's any discontinuity, it will be at 0. So f of 0, I have to use this one or that one? Which one? The bottom one. So replace x by 0. So what's the answer? The answer is A. Number 2, you want the limit to exist. Let's look at the limit from the left side. Has to equal the limit from the right side to exist. So from the left side, I have to use what? I have to use this one. That will be the limit of 9 sine of x over x. From the right side, that's going to be the limit of a minus 7x. And they have to equal to each other. Well, we know we can take the 9 out of this. If you take the 9 out, that'll be 9 times. What's the limit of sine x over x as x approaches 0? Isn't that a 1? So from the left side, that's a 9. From the right side, as x approaches 0, what do we have? A. So you want A to equal to what? 9. If A equals to 9, we have a limit. The limit is 9. The function is 9. And step number 3, they will equal to each other. So you want A to be 9 for the limit to exist. And once A is 9, there is a limit which is 9. The function will have a value of 9, and the two numbers will be matching. So that will make the function definitely continuous. But that's the first step. The limit must exist. For the limit to exist, the left side have to equal to the right side. So A has to equal to 9. Almost number 16, very similar to number 15. X squared minus a squared over x minus a. When x does not equal to a. And you want 8 when x equals to 8. And the question, find A that will make it continuous. What is A has to be? Again, you must have a limit. The function must be defined. The first step, what is f of A? When x equals to a, what's the value of that? 8. Is this defined? Yes. Step number 2, or condition number 2, what's the limit as x approaches a of x squared minus a squared over x minus a? Well, you know if you plug in a and it's going to have 0 over 0. Not good. Can we factor the top? That becomes x plus a, x minus a over what? X minus a. Which becomes the limit as x approaches a of x plus a. So let x be a, what are you going to have? A plus a, which is 2a. So we do have a limit. The function is defined. The limit exists. What's condition number 3? The answer from step 1 and step 2 have to be what? The same. So 2a has to equal to 8, which means a has to equal to 4. So the first step is find the value of the function at a. Second step, find the limit as x approaches a. And the two answers have to match. And the only way they will match if a equals to 4. We got 2 more problems. We're almost done with it. Let's look at number 17. I'm going to tell you that in 1 second. If I ever find your book, but it's not no big deal, I can tell you what that is. I was looking to see because I didn't see it last time when I covered it. I was wondering. Section 2.4. I don't see it there, but I'll explain it to you. I must have missed it. I don't know. Why is it in this section? Because I don't see it. Here's what we have for number 17. You have f of x equals x squared plus 5x plus 2. And this is good from 0 to 9. F of c equals 26. Okay. 26. Let me explain to you where the 26 came from. Can you tell me what f of 9 minus f of 0 divided by 9 minus 0, can we figure what that number is? What is f of 9? Here we go. Let me get to my calculator. This is what? X squared plus 5x plus 2. F of 9 is actually 128 minus f of 0, which is what? 2 divided by 9 minus 0. What is 128 minus 2 divided by 9? 14. Okay. Then, the mean value, is it the mean, intermediate value theorem, so the mean value theorem. I was looking for the mean value theorem, but they're talking about the intermediate. But they're not talking about the mean value. The mean value theorem, it says there has to be a function where if you take the derivative of that, it has to be a number between this and that, which we didn't cover the derivative. The derivative of that is equal to that number, which is f of 9 in this case, minus f of 0 divided by 9 minus 0. But that's not what this question. This one actually, the intermediate value theorem. F of c equals 26. So let me go back and rewrite that. Usually you see these in chapter 3. I'm curious, why is it in this chapter? It's in chapter 3 usually. Intermediate value theorem, here we go. If f is continuous, if the function is this function continuous if you graph it? What do you think? What is the shape of that function? Parabola. So f of x is continuous. If the function is continuous on the closed interval from 0 to 9, closed interval, and k is any number between a and b, if you pick a number between a and b, then there is at least one number between 0 and 9, somewhere between 0 and 9, such that f of c will equal to k. So it has to be a number between 0 and 9, somewhere that where f of c equals 26 in this case. And what is that number? That's really what they're asking for that question. Can you tell us what that number? That's the intermediate value theorem. There has to be a number between a and b there, where f of c will equal 26. So take this one, set it equal to 26. Can we solve that for c and to see if that number between 0 and 9? Bring the 26 to this side, becomes what? Isn't that negative 24? Negative 24, can we factor that to what? X minus, how about, what'd you say, 8?
Yeah, 8 and 3.
8 and 3, yep. X minus 3, x plus 8. Let's solve it. Set each factor equal to 0. X will have to be 3, x will have to be negative 8. This we can't use. Why? The number has to be between 0 and 9. It says there must be a number between 0 and 9 where the value of the function will equal, in this case, to 26. So the answer is yes, there is a value between 0 and 9, which is the 3, where f of c equals 26. So basically, graphically, that's what that means. If you have a function that's continuous, and if you graph that one between 0 to 9, looks like this. If it's continuous, and if you pick a number between these two numbers, any number between them, there has to be at least one point between this value and this value where that's c, where the value will equal to that number. That's really what the intermediate value theorem is. So in this case, you need to find the x value, which happens to be a 3. The other one's called the mean. I started talking about the mean value theorem, which is equal to this one. There has to be a value between them where the derivative is equal to that, but that's coming up in the next chapter. So not here. So in this case, c equals 3. That's what c will have to be. And the other one is the same thing. Number 18, it's the same idea. you have f of x, and mine is actually, it's x squared plus x over x minus 1, and that's good from 5 over 2 to 4. It says there has to be a value between this number and that number with a value of c equals 6. Why they chose 6? Because if you take the 4, what's f of 4? F of 4 is what? That's 16. Plus 4, isn't that 20? Over 3. What's 20 over 3? Is that 6.667? And f of 2.5, 2.5, that's 5 over 2. What's that number? .5 squared plus 2.5 divided by 1.5, 5.8. There has to be a number between these two. The 6 happens to be between them. It's going to have a value of x between these two numbers. That's what it says. If you pick a number between these two, there has to be at least one number between them where the value will land between this number and that number. And that's why they chose the 6, because it lands between these two numbers. So let's take the c and plug it in here. C squared plus c, if you don't want to use x. You can use x and solve it. It doesn't really matter if you use c or x. Multiply both sides by c minus 1. Move everything to one side. Plus 6. Factor that. Negative 3 and negative 2. C equals 3. C equals 2. This I can't use. It's outside my interval. This one is good. It has to be between these numbers. It has to be at least one value between these two numbers where the value of the function of that value is 6. And we do have one. Between 2.5 and 4, there's the 3. And the value when x is 3, that's a 6. And that's the last one.